Okay, so this is Unit 4, Objective 5, which is solving radical equations. So for the Pearson book, this is actually Chapter 6, Objective 5, which begins on page 459, and I'll be using examples out of that. So just a couple of things here. This is a key concept, and this actually came out of Unit 4, Objective 4. Right, so that would be Pearson, Chapter 6, Objective 4. And so there's just one key concept here, but we're going to write it in two different ways just to kind of make sure we understand that. So if we have x to the 1/2 power, that means we're x to the first, right? So that would be x to the first, and then the square root of x. So that 2 means 2 root x. But we don't write all the 2 and the 1, right? That's just implied. So that would just be the same as the square root of x. So when we see x to the 1/2 power, that's just the square root of x. And then still the same key concept, but just to kind of make sure we understand we don't distribute over addition with exponents. So this would be this whole thing, right? This whole grouping is the square root of x plus a, which is not, right, the square root of x plus the square root of a, right? That is a big no-no. Okay, so you don't ever want to do that, right? That is, you can't do your exponents distributed over adding or subtracting. And so you need to add first, right? Do your parentheses first, and whatever x plus a is, like whatever that value is, you add it together, and then you can root it. We can't actually add two variables together, so that means we can't do anything more, and that's just our answer, right? So we want to make sure that we don't do this, right? I don't want to ever see you guys do that, okay? All right, and then just a review idea. So this is just to kind of remind us. So this is another key concept or key review idea, that when we have something that is quantity squared, again, we can't distribute the squared over subtracting. So what we would do is rewrite it. So this means I have 2 of those. And then from there I would distribute. And these have to be exactly the same, right? I see some of us try to write x minus 5 and x plus 5, make them opposites, but they're not, right? So we need to, or conjugates. So we need to make sure that we write 2 of exactly the same. And then from there we distribute. So the x multiplies to both of these. So x multiplies to x, and also to the negative 5. And then negative 5 multiplies to both of these. And negative 5 times negative 5. And then the middle terms should combine. And so that would be distributive property, right? So if it's squared, we write it twice, and then distribute. Okay, and then the third key concept, so just for review idea, is solving for quadratics, so solving quadratics. And so that's when we use the zero product property, right? So if 2 things that are being multiplied equal 0, then either A has to be 0 or B has to be 0, right? So that's the zero product property. And how did we use that? So just to kind of remind you, if we had something along the lines of x squared minus 8x plus 10 equals negative 2, say something like that. The first thing we would do is set it equal to 0, right? So this is a little reminder idea. So we would set equal to 0 because it's the zero product property, right? Not the negative 2 product property, but the zero product property. So I would add 2 to the other side. And then after we set it equal to 0, because it's a quadratic, we're going to try to factor it. And then if it doesn't factor, we would use quadratic formula. So for 12, the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. And we would look to say, okay, which one of those sets of numbers would help us also get to this -8? And so if I look here, 12 and 1 don't add or subtract to 8. 2 and 6 does, and 3 and 4 does not. So that means I'm going to use 2 and 6. So x squared is x and x, and then for -8x, I want both of these to be negative, which still gives me a positive 12, so that would be -2 and -6. And then once I factor it, I set each factor equal to 0, and then solve. And a lot of us can do this in our head, but I'm going to still show this step. So my first factor equal to 0, my second factor equal to 0, and then I would add 2, and then add 6. So x could either be 2 or 6. Okay? All right, so these were just these are our key concepts or review ideas. And that's just to help us do the solving. So that was like a lot of stuff we have to make sure that we understand and know in order to be successful in this particular lesson. So knowing that the rational exponent can turn into my square root, making sure that if I have a quantity squared, that I do distributive property appropriately. And then when it comes down to solving, if I have a quadratic, right, we're going to use the zero product property for quadratics. So if in my process of solving, I need to make sure that I set it equal to 0, right? Always equal to 0 first, and then try to factor it, and then solve my factors. Okay, so that's just that review. So let's go ahead and do 2 examples for the new stuff. So we're going to solve for x. Okay, and so this is the problem number 1 on page 459 out of our text. So page 459, problem number 1. So our first step is to isolate the radical. So we want to make sure that anything that is outside of the radical moves to the other side. So we look to say, okay, is there a number in front? Is there a number behind it? Like, where are the numbers outside of the radical? And whatever they are, I need to move them over to the opposite side. And that's just doing our inverse operations. So for us, so any outside number, right, which in this case is the -5, I want to move it over to the equal 0. So the inverse of subtracting is adding, so I'm going to add 5 to both sides. And that leaves the root of 4x plus 1 still. And the -5 plus 5 cancel. And then, or 0, right? And then 0 plus 5 is just 5. And then once the radical is isolated, meaning there's no number in front, no number in back, then I want to square both sides. And when I do that, I need to make sure I'm quantity squaring. So I square everything on the left, square everything on the right. So we're going to square both sides. And again, making sure we're quantity squaring. So right here, I'm going to do square and then square. Okay, so I did the whole thing over here squared, and then everything over here is one group squared. So we know that the square root of something squared is just 4x plus 1, right? And then not absolute value, right, because this is implied positive. And then 5 squared is 25. Okay. And then from here, we're going to just solve for x. Which always sounds easier than it sometimes is. So we have to be careful. There's either the simple solving, meaning you're just going to, add, subtract, multiply, divide things. So I'm going to call that simple solve. And then the other is solved by factoring. And we know to solve by factoring if it's a quadratic, meaning is there an x squared in my problem? Okay. So if I look, there is no x squared anywhere, so I'm going to just do simple solving. So to isolate the x, I need to get rid of the 4 and get rid of the 1. And I want to do inverse order of operations, so that means I'm going to subtract 1 first. And then divide by 4. So then x equals 6. Okay? All right, and then let's do another one. Okay, so I'm going to talk real quick here about extraneous roots, because that's going to be for our next step here. Oops, spelled this correctly. That's an O. Okay, so we're going to be creating something called extraneous solutions or extraneous roots. And usually what happens here is we turn a square root function into a quadratic. And so that creates an extraneous solution. So an extraneous solution is when a radical equation turns into a quadratic equation. So we don't know this yet because we haven't actually done our graphing of our square roots. That's not until our next lesson, but just to kind of give you an idea of what we're talking about. So we don't know what the square root graph looks like, but I'm going to just tell you that that's what a square root graph looks like. So this is what, y equals root x looks like. And what's going to happen is when we are solving and square both sides, we're going to end up with something that is squared. So we're going to end up with our original graph, but then it's going to create another half of that because we're squaring it. So it turns into kind of a parabola shape. And so that gives us a graph that kind of looks like that. And so when we create our equations, we're going to have now two branches where we're going to get two solutions, but we know we really only have one branch to begin with. And so I know that's kind of confusing because we don't know the graphs and we really aren't, to that point yet. But just to kind of give you an idea of what's happening when we get extraneous solutions is that we start out with a radical equation that has a very restricted domain, right? Our values of x have to be positive, or the solution has to generate a real number. But then when we square it, now all of a sudden it says, oh, yeah, it's okay to have these negative numbers down here. And we have that new branch that's created because we create this parabola. And so that's what's going to evolve and create these extraneous solutions. So whenever we have a quadratic equation that we're solving, so whenever we're solving a quadratic equation, we have to check for extraneous solutions. That is a must, not a, I feel like it or whatever kind of thing. So the key idea here, so the idea that we need to make sure that we are understanding is that if we have to, when we're solving radicals, if we generate a quadratic equation, meaning we solve by factoring, oops, let me scoot this up just a little bit. Then we check for extraneous solutions, meaning we get a false answer. Okay, so that's what we have to make sure. So an extraneous solution meaning we get two answers, but one of them really doesn't work. Okay, so if we solve by factoring, we must check for extraneous solutions, right? So that's the key idea. So one of those two answers probably isn't going to be a true solution, okay? So let's go ahead and do an example that would generate that so you can kind of see what we're talking about. Okay. So this is example B, which is problem number 4 on page 462. So this is off of page 462, and it's just problem number 4 out of our book. Okay, so we're still going to follow the same steps. So let's just kind of look at these again just to review them. So our first step was we want to isolate the radical. So anything outside of the radical, we want to move to the other side. Okay, right? So that was our step 1. So for us to isolate the radical, okay, so we're going to subtract 3. That just gives us 0. Okay. And then there is nothing else outside of the radical. And so then if we look at step 2, so let me scoot this over so we can see both of these at the same time. So then step 2 was we want to square both sides, right? So we've isolated the radical, which was step 1. So step 2, we want to square both sides. And when we square both sides, I have to square this whole thing, right? I got a quantity square. So the root squared is just 5x minus 1. And now this is squared, right? So this was key concept at the very beginning, key concept number 2, where we want to write it twice. And then we need to distribute, right? So x minus 3 squared, we want to write it twice and then distribute. So all I did was multiply x to the x and to the negative 3, and then negative 3 to the x and to the negative 3. So now I'm going to combine like terms. Okay, so all I've done is square both sides, distribute, combine like terms. So now if I look at step 3, I need to do solve for x. So do I get to do simple solving? And when I look here and I say no, I have to solve by factoring because I do have a quadratic. So I'm solving by factoring because I have an x squared in the problem. So now that also means, so now let's flip to the extraneous solution part. When I'm solving radicals, if we generate a quadratic equation, meaning we have an x squared, meaning we have to solve by factoring, that means we're probably going to have an extraneous solution and I need to find that. Okay, so one of my 2 answers will not generate, or will not be a correct solution, and then will therefore be extraneous. So just to remind you, to solve by factoring, it has to be equal to 0. So I'm going to move these 2 terms over to here. So I'm going to add 1. And then at the same time, I'm going to go ahead and subtract 5x to the negative 6x. That's just to save a step. So all of this will turn into 0, right? So 5 minus 5, negative 1 plus 1. And then negative 6x and negative 5x. And then 9 and 1. And so now I need to factor this. So I'm going to think of numbers that multiply to 10. So 1 and 10 and 2 and 5. And which of those pairs will help me get the 11? And 1 and 10 would. 2 and 5 won't, right? Because that's either 7 or 3 when I add them. And in order for it to be negative 11, they both need to be negative. And when I multiply, still gives me positive 10. So then this would be 0 equals x minus 1, x minus 10. Okay. So then solve by factoring. So it's factored. Now set each factor equal to 0. Whoops. And then add 1 to both sides. And add 10 to both sides. So in terms of my solutions, I know for the quadratic, my solutions are 1 and 10, but one of these would generate a false answer. So to check, I just need to substitute into the original problem, and then I'll show you a shortcut as well. But we're going to do the check first. So is x equal 1 a real, does it really work, okay? So to do that, I go back to my original equation. So that was up here at the very beginning. Oops. Okay, so I'm looking up here, and anywhere I see an x, I'm going to replace it with a 1. Okay, so I want to do 5, and then instead of x, 1 minus 1, add 3. And I want to know, does that equal x? And x again was 1. So I don't know if this is true or not. Okay, that's what I'm checking. So I'm looking up here at the original, and everywhere I saw an x, I replaced it with 1. Okay, so now to simplify, so I'm not solving, I'm simplifying. So I want to see, does this really equal 1? So this is 5 minus 1, which is 4. Square root of 4 is 2. So does 2 plus 3 equal 1? No. Okay, so then that means x equals 1 is my extraneous solution. Okay, so that means x cannot equal 1 for my original problem. It works for the quadratic, but not for the original. So x is equal to 1 is my extraneous solution. So I'm going to check with 10. So 10 should work, but I'm going to check it anyways, just in case I messed up on the 1. So I'm going to go back again to the original problem, so slide down. And so wherever I see an x, I'm going to replace it with a 10. So this would be the square root of 5, and then 10 minus 1 plus 3. And I want to know, does that equal x, which is 10? So hopefully it does, because one of these should work, right? So then this would be 50 minus 1. So 50 minus 1. So I'm simplifying, not solving. So the square root of 49 is 7, and does 7 plus 3 equal 10? Yes. So then 10 is my solution. Okay, so now for the shortcut. So this may not make sense to people, which is fine. Okay, but one thing that you can do real quick here is you know that this has to be positive, right? You know that this has to be positive. So let me do this off to the side here. And this is a shortcut with the idea of understanding what you're doing. So it's not like a shortcut in the sense of, ooh, it's a shortcut. What's the little tricky trick? This is for those of you who are, have a better understanding of what the heck we're doing. This is a way for you to say, oh, right, okay, I get it. So we said that our solutions were 1 and 10, right? So we know that this has to be a positive number because otherwise it's imaginary, right? So we know that our square roots have to generate positive numbers. So if x were 1 over here versus if x were 10 over here, which one of these generates a positive number? So if I let x be 1, 1 minus 3 is negative 2. If I let x be 10, 10 minus 3 is 7. So because when x equals 1 is substituted in here and gets a negative 2, I know that's not true. It can't be. This has to generate a positive number. So that tells me that 1 is my extraneous solution. Okay, and then 10 substituted in is a positive number. 10 minus 3 is 7, so it has to be that one there. Okay, so that's kind of the shortcut, and then that's it for solving.